everyone, my name is Fatia and today we are going to learn about nuclear energy in 15 minutes. Are you ready? So let's start now. For today's video, I hope that by the end of this lesson, you will be able to explain first nuclear fission and another one nuclear fusion. Before getting into this, I would like to ask, what is nuclear energy? Nuclear energy is known as atomic energy released during nuclear reaction such as radioactive decay, nuclear fission, and nuclear fusion. Now, what is nuclear reaction? Nuclear reactions are processes in which one or more nuclides are produced from the collisions between two atomic nuclei or one atomic nucleus and a subatomic particle. The nuclide produced from nuclear reaction are different from reacting nuclei. So the reacting nuclei over here is referred as parent nuclei. Okay, since I have already mentioned about nuclear reaction, let's go to the type of nuclear reaction. Nuclear fission and nuclear fusion are two nuclear reactions that produce nuclear energy. So, in order to produce nuclear energy, we will need nuclear fission and also nuclear fusion. Okay, so firstly, let's talk about nuclear fission. What is nuclear fission? It is a nuclear reaction when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. It is like this. The neutron hit on nucleus, then fission occurs, releasing fragments and large amount of energy. And not to forget, neutrons also released over here. Okay, next, this is the example in KSSM Physics Form 5 textbook. So, basically, it is shown that a uranium-235 nucleus is bombarded by a neutron. So, a fast-moving neutron collides with the uranium-235. And then, it will make or produce an unstable uranium-236. Why 236? Because it have added another neutron. Okay, so an unstable uranium-236 nucleus is produced. And then, a barium-141 nucleus and a krypton-92 nucleus and 3 neutrons are produced. And not to forget, energy is also released over here. So, this is the process. Okay, now, have you ever heard about nuclear reactor? You know, the one which some countries are using to supply their electricity? So, this is an image of nuclear reactor. But sadly, we do not use this in Malaysia. But in some countries such as United States, Japan, they are using this kind of source in order to supply their electricity. Do you know what type of reaction occur there? Nuclear fission occurs there. But how? Okay, so today I would like to show you the process which occurs in the nuclear reactor. So this is basically the process which is happening inside of a nuclear reactor. So we basically have a reactor, a steam generator, water pump, turbine, condenser, generator, and also cooling tower. So, before getting the electricity, what kind of process actually happen in the nuclear reactor? Actually, I have already mentioned it to you before, right? It is nuclear fission. So, inside of the reactor, nuclear fission of uranium-235 and its chain reaction will produce heat energy. So, from this heat energy, it will produce like a steam, and then will generate the turbine and also generate the electricity in the system. But I am not going to talk about the whole process of generating the electricity, but we are going to talk about nuclear fission over here. So just want to make sure that you still remember what is nuclear fission. Nuclear fission is a nuclear reaction when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. Then, this is the chain reaction of uranium-235. In a nuclear reactor, the fission of uranium-235 nucleus will produce two daughter nuclei, three fast-moving neutrons, and also release a large amount of energy. This neutron will bombard other uranium nucleus, and then the process will release more neutrons through continuous nuclear fission. This continuous reactions is known as a chain reaction. Okay? Are you still with me? Okay, now we are done with the nuclear fission. Let's take a look at nuclear. What is nuclear fusion? How is it different from nuclear fission? So, as for nuclear fusion, it is a nuclear reaction in which small and light nuclei fuse to form a heavier nucleus while releasing a large amount of energy. This nuclear reaction happens under extremely high temperature and pressure. Okay, so for nuclear fission, it comes from heavy nucleus splits into two or more lighter nuclei, right? But for nuclear fusion, it fuses to form a heavier nucleus while releasing a large amount of energy. So this is the example provided in the KSSM Form 5 textbook, physics textbook I mean. Okay, so for the example, we have nuclear fusion between deuterium and tritium. So we have deuterium and tritium occurs to form a heavier helium nucleus, and also we have energy release, and also neutron is also released. So it produces a heavier helium nucleus, energy, and also neutron. So this is the situation that occur for nuclear fusion between deuterium and tritium. So this is in order to help you to visualize it better. Okay, now everyone have seen a sun in their life, right? The sun actually provides light and heat energy to Earth since millions of years ago. But why did I mention sun in this lesson? This is because one of the nuclear reaction occurs over here. Guess what? Hydrogen nuclear fusion occurs in the core of the sun under very high pressure. In this nuclear reaction, two hydrogen nuclei fuse to form a helium nucleus and release nuclear energy. So, This is the image of light and heat energy radiated to the surface of sun. So this energy is radiated to the surface of sun in form of light and heat energy. Now, let's compare nuclear fission and nuclear fusion. In terms of definition, nuclear fission is the splitting of a large atom in two or more smaller ones, whereas nuclear fusion is a fusing of two or more lighter atoms into larger ones. So basically, this one is from large to small, and fusion is from light into large. As for the occurrence, nuclear fission does not normally occur in nature, whereas nuclear fusion occurs in stars such as the sun. For energy requirement, nuclear fission takes little energy to split two atoms in a fission reaction, and then nuclear fusion needs extremely high energy in order to bring two or more protons. In terms of energy release, nuclear fusion have 3 to 4 more times greater than nuclear fission. And lastly, for energy production, nuclear fission is used in nuclear power plant, and whereas nuclear fusion is used in an experimental technology for producing power. Since both going to release energy, that is why it is used for energy production. Okay, next. Now, I have a question to ask. What type of reaction is this? We have a fast-moving neutron bombarding into uranium-235, and then the process repeating itself. And it will produce neutron and also daughter nuclei over here. So, what is the type of reaction? Is it fission or fusion? Okay, the answer is nuclear fission, or specifically the chain reaction of nuclear fission occurs over here. Now, using the same image, let us try to explain the process of nuclear fission or the chain reaction of nuclear fission over here. So, over here, a uranium-235 atoms absorb a neutron and fissions into two new atoms, and also releasing 3 new neutrons and also energy. So the neutrons is over here, and the star shape over here represent the energy. And when another neutron hits on other uranium-235 atoms, that atom will repeat the same process as before. That is why it is called as chain reaction. Okay. So let's take a look at this statement. Energy is released when two or more lighter nuclei combine to form a heavier nucleus. So what is the name of this process? Is it nuclear fission or nuclear fusion? Okay, so it goes from light to heavy. So the answer is nuclear fusion. So basically, both nuclear fission and nuclear fusion will release energy, right? However, for nuclear fission, it is the splitting of a heavy nucleus into two lighter nuclei, whereas nuclear fusion is the combining of two light nuclei to form a heavier nucleus. Okay, that would be all from me. I hope that after this, you can explain nuclear fusion and nuclear fission really well. Thank you for lending your ears. Bye!